Built by Rocketdyne Corporation, the Space Shuttle Main Engines use liquid hydrogen and liquid oxygen as propellants. But we breathe oxygen in the air, right? Well, yes. Normally found as gas on the periodic table of elements, both hydrogen and oxygen can change from gas into a liquid. Extremely low cryogenic temperatures do the job. When these low temperatures are introduced, the molecules slow down and a physical change takes place. Now, when liquid hydrogen and liquid oxygen meet, something else takes place.
With exhaust temperatures reaching 3,315 degrees Celsius, this created a design challenge for the early space shuttle engineers. They knew of no metal that could withstand such extreme temperatures without melting. So, they created their own metal alloy. It was a mixture of copper, silver, and zirconium. It could bend and flex quite a bit without breaking under the strain of the launch. Plus, it was an excellent conductor that helped transfer the thermal energy away from the more delicate engine components. An extra cooling system diverted a little liquid hydrogen propellant through tubes within the nozzles and kept the Space Shuttle Main Engine cool to the touch. Every engine that has ever been placed on an orbiter has been tested first. More than 2,300 test firings helped NASA fine-tune the complex main engine that was built with 50,000 parts. Just like stepping on the gas pedal, these engines were designed to adjust the throttle or the power output of the engines. But sometimes when you're innovating, things have to go wrong before they can go right.
Consequently, the shuttle got a lot of ridicule early on in the media, in the editorial cartoon pages of the newspapers and such. They were kind of making fun of the engines because they were still having some fires when they were doing test firing, and questioning, is this vehicle, this most complex spacecraft ever attempted, ever really going to make it off the launch pad?
Engineers continued refining the engines until they worked more reliably. See the diamond shape in the exhaust? This is called a Mach diamond, and it showed that the engine was healthy and running at full speed. Plus, a central computer system monitored sensors throughout the engine at 50 checks per second.
To this day, the innovations of the Space Shuttle Main Engines make them the best performing chemical rockets on Earth, and the only rocket engines designed to fire constantly from launch pad to orbit.